Creating a data file for analysis involves at least a couple of steps and can seem overwhelming, but if we take it step by step, it isn't too bad. The first step is to put the data in an electronic file, if it isn't already, and format it in a way that will make it easier to conduct the analysis. Things like naming variables and coding data are small details that can make a big difference later. In learning about data files and statistical analysis, we'll use a similar process to what we've done with other topics. I'll walk you through all of the steps for an example based on one survey. You'll practice with information from a different survey and check your work. Then you'll complete the process a third time on your own. If you haven't already looked at the guides, you might do that after you watch this video. They'll help refresh your memory as you practice and work on your own. This is a good time to note, too, that the data will be used for the examples and activities is only for the purpose of learning about the process. It isn't a real data set. Now, on to the featured attraction. If we have data on paper, we need to enter that data. In those cases, we can create a data file in SPSS and save a step later. I'll include the resources about that in the class materials. Sometimes it's more practical to start in Excel, though. For example, if we use a Google form to administer a survey, we can download the data into Excel. We just open the file in the Google Drive, go to the File menu, select Download As, and select Excel. It'll open the full data file then in Excel. It'll look like the worksheet in this slide. You might have already noticed the file looks a little overwhelming and doesn't seem like something we could analyze with statistics. It's a good call, and part of the reason we need to work with it. SPSS calls each of the questions in the data set a variable, and the responses to each question are called data. The data downloaded from the Google form identifies each question, or for each variable, by putting the full question in the first row of the column and the data in the following rows. SPSS won't be able to work with having the full question in the first row. SPSS doesn't work with spaces, among other things. Having that much information also makes it complicated for us. So the first thing we'll do is change the first row. Looking at the Excel file full of information can be a little disorienting, and the examples might even be more so since you didn't go through the steps to design the study and gather the data. Sometimes there's enough of a delay between designing the study and analyzing the data that it feels pretty foreign, too. The process of making sense of the information isn't too complicated, but it helps if we have good notes about our measure and organize our files so they're easier to find. To be honest, it usually takes me more time than necessary because I have to remember where I put the information that I need. That said, the information we're looking for is the same information we needed when we were locating the measure for the study. You might remember the examples for that process talked about measuring a variable called grit. I found most of the information I needed, the questions, response options, scoring information, by backtracking from a study that measured grit. The citation and reference in that secondary source led me to the article talking about how the measure was written. Now that I have that information, I can figure out which column in the spreadsheet includes the data for each question. My notes for a measure usually include a screenshot of the table like this one for my measures. Aside from the questions themselves, there are two other pieces of information that are important to keep in mind. The first is that this table includes questions for both the original short grit scale and the short form. I used the short form, so I need to remember the data file is only going to include the questions in italics. I know that because the note at the bottom of the table that is circled in this slide. I also need to make sure I'm numbering the questions accurately in my file because it'll make it a mess of other steps if I don't. This table makes that a little tricky because they didn't put the questions in numerical order. I circled number 1 and number 2 in this slide to point that out. After I locate the information I need, the next step is to figure out which column in the spreadsheet includes the data for each question. The Google form includes the full question, so I have to click on the cell to see the information I need, the actual statement the participant was responding to. In the example data file, the first column was the timestamp, so the next one's the first question that the participants responded to. The information in the brackets says, new ideas and projects sometimes distract me from previous ones. When I find that statement in the table from the article, I see it's question number 2. To create a variable name, I change the cell with the question to an abbreviation for the measure name and the item number. When we get to the steps that involve reverse scoring and computing scores, you'll see why it's really important to have the correct item number with the data. You might have noticed I messed up a little bit when I created the survey. It should not have started with question 2. For some reason, I didn't enter any of the questions in order. The numbering in the key for the short grit scale does skip a few items because it's presented in terms of the items from the original measure, and some were included and some weren't. It still would have made sense, though, for me to keep them in the order it was in, and it might create concerns about validity if the order of the questions made a difference in what the participants were thinking about when. At a minimum, it means I can't just number them 1 through 8. After the first row is edited to create variable names, we can move on to the process called coding data. When we work with statistics, we usually treat scale scores like this as if they represent the interval scale of measurement, even though a strong argument can be made that they're really ordinal or nominal. We have to code the data because we can't compute mathematical scores using the words from the responses. Giving the participants the words, though, can be more helpful than giving them the numbers. So how do we know where to find those numbers? They may be included in the article about how the measure was developed, and in the case of the short grit scale, they were. In other cases, we can look at other studies that use the measure to see how the numbers were assigned. At this point, you might be asking yourself why it matters what numbers we use. Why does it matter if I use 0 for the lowest number instead of 1? That's a great question. It comes back to the idea that research results are meant to be shared. That process of sharing also allows for comparison across samples or populations, as well as meta-analysis. If the responses aren't coded consistently, though, those comparisons aren't valid. Part of the reason I start working in Excel is because that program helps me make quick work of the coding process. One approach is to look at each response in the data file and change it manually. In other words, to look at cell B2, see that it says very much like me, and change that to a 5. Then go on to cell 2 and see it says mostly like me, and change that to a 4. If it's painful to listen to me describe that, can you imagine doing that for all 8 questions for every participant? Hopefully, you would question the validity given the possibility for error. The good news is we can be strategic to work faster and to work more accurately. In Excel, you can hold down the Control button, the one that's labeled CTRL, and hit the H key at the same time to access the Replace dialog. From there, we put the wording for the response option in the top box and the number in the lower box. Then we click Replace All. Excel will go through and change all of the fields, and you'll see a notification it's done. We need to repeat that step for each of the 5 response options. But what if you get a message that says it couldn't find any responses to replace, and you can see one right there? If you copy and paste the response options, make sure to delete any extra spaces at the end or the beginning. The search feature is sensitive enough, it will say it can't find the phrase because it doesn't have that space. If you typed out the response, check for typos. The same basic reason we get an error when there are extra spaces means that we have to think about the best order to replace the responses. The options for the short grit scale didn't present a problem, but shorter labels can. For example, if you had the scale in this slide and went in order, after you replaced all the agrees, all of the disagrees would end up being dis2. To avoid chaos, you need to go in the order they're listed on the right. In theory, you could change all the dis2s to be 3s, but then you'd have to change all the strongly 3s to 4s. It's actually easier to make the changes out of order. This is a good time to note that we don't need to throw out responses from a participant if they did not answer every question. SPSS adjusts analysis as necessary so we can use the data that's available without messing up the results because of the missing data. For example, in our data file for the short grit scale, you might notice row 16 is missing a response for question 4. That's not a problem. In other cases, participants might respond in a way that does not represent a valid measure. Some scales use reverse scored items to help detect that. In other words, they include questions that should have different response than the others. We don't need to worry about those details for now, but it's good to keep that idea in the back of your mind when you think about what to look for when you collect data for other purposes. In some cases, Excel can compute what we need for analysis. It's limited though, and the SPSS program can actually be easier once we get used to it. Our next step then is to move the Excel file into SPSS. The next recording will guide you through that process.